Okay, now how do we use these things? Why do we worry about these kinds of things? Well, how do we combine numbers with the appropriate number of significant figures? For example, how do we multiply numbers? Well, let's imagine that we're going to multiply, let's say 2.23 by 5.8943. And you do this on your calculator, and what you get is 13.144289. So that's what your calculator tells you. Now, is it really appropriate to say that the answer of this product has, well, let's see, 1, 2, 3, 4, 5, 6, 7, 8 significant figures? Is it really appropriate to say that this number times this number is really something that we know to a precision of 8 significant figures? Well, let's think about it. If we've got this number 2.23, in terms of what we have said before, we are saying that that is a quantity that really is probably somewhere between 2.235 and 2.225. We're really saying that that number is probably somewhere in between this range. While this number really is somewhere in between 5.89425 and 5.89435. So this number is somewhere in between this range. So this product could be anywhere between a low value of these numbers multiplied and a high value of these numbers multiplied. Well, what do we get if we multiply these? Well, multiply those out and we get 13.11470,625. And if we multiply these, we get 13.17387,225. So what we are saying is then the product of these numbers really could be anywhere between this low value, approximately, and this high value, approximately. So how accurately can we really quote our product of these two? Well, can we say that it's really 13? Well, yeah, we're in between, say this is 13 and 13, so yeah, we can say 13. Can we say 13.1? Well, yeah, this is 13.1, this is 13.1, so we can say 13.1. Can we say 13.14? Well, all we really know is that it's probably somewhere in between 13.11 and 13.17. So is it really fair to quote that next digit, a 4? Well, no, because we really don't know. It could be maybe a 1, 2, 3, 4, 5, 6, 7. So really, we can only quote this product as 13.1. Any more digits we really are not sure about. Well, there we go. So what we will do is then we will quote this result as not 13.1 blah, 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 blah. We will quote this as 13.1. And that is our product. Well, we might look at this and kind of develop a very general rule of thumb. And what we see is that we have how many sig figs in our first number? We have 3. How many sig figs in our second number? We have 5. When we multiply a number with 3 sig figs with a number with 5 sig figs, all we can keep are 3 sig figs. Well, the general rule of thumb that we will use is when we multiply quantities, we count the number of sig figs in the numbers we're multiplying. Whichever number has the fewest number of significant figures, that will be the number of significant figures in our product. So in this case, we've got 3 and 5. Which one's smaller? The 3. So how many sig figs can we keep in our answer? Well, that will be 3. And there we go, 13.1. What you can do is just multiply them on your calculator and then just keep 3 significant figures from your final answer. There we go. So, Let's try another one. Let's say we take 3.0 times 5.158. If you do that on your calculator, what you'll get is 15.474. So, what will we quote as our answer? Well, how many sig figs do we have here? There's a decimal point, so that's significant. We've got 2 here. How many here? 1, 2, 3, 4. So how many can we keep? Well, we've got 2 and 4. 2 is smaller, so we can only keep 2. So what is 15.474 with 2 sig figs? It's just 15. There we go. So there's our answer. 3.0 times 5.158 is 15. What about 3.24 times 1.89763? If you do that on your calculator, you'll get 6.148312. What are we going to keep? What's our answer going to be? Well, how many sig figs do we have here? 3. How many do we have here? 1, 2, 3, 4, 5, 6. So 3 and 6. How many will we keep? Well, 3 is less than 6, so we'll keep 3. So what is this to 3 sig figs? 6.1. Now this, notice, is 8. So 4, 8 is actually closer to 5 than it is to 4. So we'll round this up and we'll make that 6.15. So when you're rounding, the rule that we'll use is if the next digit is a 0 to 4, we'll just drop it and round down. If it's a 5 to 9, we'll round up and we'll make this 5. Now, sometimes some people will use a rule that they'll always make this digit even or always make it odd or something like that if this is a 5, so that a 5 will either round up or round down. Well, the way I think about it is if it's a 5, yeah, that's right in the middle, but these digits out here are probably not all exactly 0. You've probably got some digits way out there somewhere, which actually makes that number closer to the higher number than the lower number. So I'll always say 5 rounds up. So 5 to 9, round that digit up. So in this case, what do we get? 6.15. Okay. Now division works exactly the same way. If you are dividing numbers, just count up the number of significant figures. So, for example, I'll write this one in scientific notation. Let's say we have 1.67 times 10 to the 3, and divide that by 3.2875 times 10 to the 2. Let me just emphasize something right here. This is a problem I've seen my students have over and over again. If you are putting this in your calculator, if you actually put the numbers in your calculator like this, 1.67 times 10, and you use like the little raised to the power or the up arrow symbol, 3, and then divided by 3.2875, times 10 raised to the 2 power. You use either, raised to the 2 power, and you use either the up arrow or something like the y to the x power, something like that. If you do that, your calculator will take this number, divide by this number, and then multiply by this number. In other words, it will put this number in the numerator. Now, you can either solve that problem using parentheses. You can put these in parentheses like that. You wouldn't need parentheses here, but you definitely need parentheses here, so that your calculator groups these two quantities together. A simpler way of solving this problem, and what I really would emphasize that you do, is most calculators have a button that tells your calculator you're putting the number in scientific notation, and often it looks like EE. So that if you write this as 1.67, or if you enter it into your calculator this way, 1.67 EE3 divided by 3.2875 EE2, your calculator will group that. This means times 10 to the power of this. Your calculator will group that together and think of it as a single quantity divided by this as a single quantity. And then you don't have to use parentheses. Typically, check it with your own calculator and make sure. You typically won't have to use parentheses, and the fewer parentheses that I use, the less likely I'll end up forgetting something or misgrouping numbers. So I try to avoid those if possible. So if you can find this on your calculator and use it that way, it will make things easier. Okay, so imagine you put this in, however, you put it in correctly, and your calculator then gives you a number, and it should give you something that looks like 5.079848. How would we actually quote this? Well, we've got 1, 2, 3 sig figs, 1, 2, 3, 4, 5 sig figs. Which one's fewer? 3. How many do we keep? We keep 3. So what is 5.079848 to 3 sig figs? It is 5.08. Again, rounding up. So we would just say that this result then is 5.08. You don't need to always write down the complete number and then show how it rounds up. We would just leave it right like that and say the answer is 5.08. Okay, so let me ask you a question. Might seem like a silly question, but what is 3 times 4? Now, probably you're tempted to say 12, but I want to emphasize that 3 times 4 is actually 10. Why is it 10? That seems ridiculous. Everyone knows 3 times 4 is 12. Well, how many sig figs here? 1. How many sig figs here? 1. How many sig figs can we have in our answer? Well, what is 12 with only 1 sig fig? It is 10. So 3 times 4 is 10. But let's keep in mind, what are we talking about here? Assuming that these actually come from maybe some measurements or something like that. Perhaps we have a room and we're trying to determine what's the area of our room. And we measure one wall and it's about 3 meters and the other wall is, say, about 4 meters. What's the area? 3 times 4. Well, let's keep in mind, when we say 3, we really mean something that could be anywhere from 2.5 to 3.5. And when we say 4, we mean something that could be anywhere between 3.5 and 4.5. Well, 2.5 times 3.5 is 8.75. And 3.5 times 4.5 is 15.75. So the area of our room could be anywhere between 8.75 and 15.75, roughly speaking. Is it really fair to say that it is 12 accurate to a single square meter? Well, perhaps not. Maybe we really can only say it's about 10, which means it's maybe somewhere between 10 plus or minus 5, between 5 and 15 or something like that maybe, which really is much more consistent with the limits of what the value actually is. Okay, there we go. So that's how we multiply and divide numbers with the appropriate number of significant figures. Now, what about adding? How do we add numbers? Well, this is actually a little bit more complicated than multiplication and division. Let's start out by trying to add numbers in scientific notation. If they're not in scientific notation, it's easier, so we'll do the harder one first. Let's imagine we have, say, 5.86 times 10 to the 6th plus 1.07 times 10 to the 4th. So we want to add these together. How do we go about doing that? Well, if they're in scientific notation, the first thing we have to do is write them with the same power of 10. If they're not in scientific notation, they don't have powers of 10, you don't need to worry about it. So, if they are in scientific notation, write them with the same power of 10. And I would suggest write them with the larger power. So the same power and choose the larger one. Well, we've got 10 to the 6th and 10 to the 4th. Which is the larger power? 10 to the 6th. So we're going to write both of these with the power of 10 to the 6th. 5.86 times 10 to the 6th plus, now I'm going to write this with the power of 10 to the 6th. If we increase that side by 2 powers of 10, from 4 to 6, we have to decrease this side by 2 powers of 10 so that the product remains the same. Well, decreasing this by 2 powers of 10 means moving the decimal point over 2 places, which gives us 0.0107. So we now have this plus 0.0107 times 10 to the 6th. Now we can factor out the 10 to the 6th, and we have 5.86 plus 0.0107 times 10 to the 6th. Now let's add these two quantities together. What do we have? Well, let's write them like you used to when you first learned addition. 5.86 plus 0.0107. And what do we get when we add these together? Well, let's think about this. We've got 7 plus up here. Now, what's this thing up here? Well, it's not a 0. If it was a 0, we'd have a 0 in there. So what is this number up here? Well, the fact is we don't know what that is. We don't know what that digit is. Likewise, what digit is over here? Well, we don't know what that is either. So what is 7 plus we don't know? Well, we don't know. We don't know what goes there. What is 0 plus we don't know? Well, we don't know that either. What is 6 plus 1? Well, we do know that. That is 7. What is 8 plus 0? Now, that we know that that is a 0. It is not a significant digit, but we do know it's 0. So 8 plus 0, well, that's 8 and 5. So what we have is 5.87. We don't know, we don't know. So what's the answer? It is 5.87 times 10 to the 6th. And that is our final result. 5.86 times 10 to the 6th plus 1.07 times 10 to the 4th is 5.87 times 10 to the 6th. The general rule of thumb here is not quite so obvious. Now, it looks like from this example that I chose, 3 sig figs and 3 sig figs, and we get 3 sig figs, but we cannot count up the number of significant figures like that. Let me give you a quick example without scientific notation. Let's imagine we have 4.32142 and we are adding 0.023. So maybe that's what we get, then both of these are times some power of 10 or something like that. So let's write this over here, 0.023, and what do we get? Well, here we don't know. We don't know. 1 and 3, 4. 2 and 2, 4. 3 and 0, and 4. So what we end up with here is this equals 4.344. So notice we have 6 significant figures, 2 significant figures, and we end up with 4 significant figures. So we cannot just count up significant figures to get the answer and figure out how many sig figs we need to keep. What we have to look at are the number of decimal places. Notice, in this case, we have 1, 2, 3, 4, 5 decimal places. Here we have 1, 2, 3 decimal places. Choose the number of decimal places which is the fewest. In this case, we have 3 is less than 5, so we keep 3 decimal places. There we go. Our answer has 3 decimal places. So, with addition and subtraction, we have to look at the number of decimal places, not the number of significant figures. But we have to look at the number of decimal places after we've written both numbers with the same power of 10 if they are in scientific notation. If they're not in scientific notation, we know that this is basically like times 10 to the 0 times 10 to the 0. So you have to write them with the same power of 10 before you can actually count up the number of decimal places and add them together. And then subtraction is the same rule as addition. You have to count up decimal places. What I would suggest is basically add them together like you would all together, and then just keep the number that you need at the end. And that will give you an extra digit that you can use to either round up or round down that will allow you to find the final answer. Okay, so those are the rules that we will be using for scientific notation, yes, but for significant figures, combining numbers with significant figures, counting up numbers of significant figures. We'll be using this all semester, both in 1111 and if you take 1112 in that class too. So that'll be something to really make sure you understand.